Good afternoon, everyone. My name is Maria Sikova, and I'm glad to present you a report on the topic of low temperatures impact on the metabolic activity of ammonifiers. Ammonifiers are microorganisms that participate in the process of converting organic residues into mineral components, including nitrogen. High metabolic activity of ammonifiers requires a certain level of temperature. At the same time, low temperature can have various negative consequences for their functioning. So first of all, let's talk about relevance. In the North climate, where even in the summer period, the temperature can remain below the optimum for even mesophilic microorganisms, the vital activity of ammonifiers like other bacteria slows down. It makes it difficult for mineralization processes in soil and leads to the delay of decomposing plant and animal debris. So my research objective is conducting a comparative analysis and identifying the peculiarities of function of mesophilic and pseudophilic microorganisms in low temperature regions. And methods were a literature review and a laboratory study. Overall, there are four main reasons of low temperatures affection on the ammonifiers. The first of them is that low temperature will slow down every metabolic process. The second one is that low temperature can lead to changes in microbial communities and even lead to the death of ammonifiers. This may be due to a lack of nutrients, changes in pH, or the accumulation of toxic compounds in the soil. The third one is lack of oxygen. With low temperature, the oxygen that contains in the soil is reduced, which can lead to very slow or absent metabolic activity. And the last one is accumulation of metabolic products. If ammonifiers do not produce enough energy in cold conditions, they may begin to accumulate metabolic products such as ammonia or carbon dioxide, which can also lead to changes in pH and the emergence of toxic conditions for other microorganisms in one um, uh, biological and ecological cycle with ammonifiers. Overall, there are two main groups of microorganisms that can function in rather low temperatures. First of them is mesophilic microorganisms. This group can break down organic waste and convert it into ammonia at optimal temperature from 20 to 45 degrees. These microorganisms have optimal conditions for their vitality at moderate temperatures and usually prefer not too extreme conditions. Mesophilic ammonifiers are one of the key elements of the cycle of organic waste. They take on the task of processing organic materials related to the animal and plant world and converting them into mineral components. Certain types of microorganisms from the group of mesophilic ammonifiers, such as Anthracomonas and Nitrobacter ones, are involved in the so-called process of nitrification, which involves the conversion of ammonia to nitrates. This is a fundamental process necessary for the sustainable functioning of biological systems and agriculture in whole sense. Also, mesophilic ammonifiers can be found in various places, including soil, water bodies, food industry waste, as well as in the wastewater treatment systems. They're part of the biological cycle of organic waste, and they playing an important role in maintaining ecological balance. The second group are psychophilic ammonifiers, and this group of microorganisms prefer more external agents than mesophilic ones. They can um, produce all of their activities uh, at temperatures below 20 degrees, often in range from 0 to this means that telecommunications are able to work in conditions of low temperature that can be critical for many other microorganisms. Also, they play an important role in a biogeochemical cycle of cold ecosystems such as Arctic and Antarctic regions, where they help in processing of organic waste and maintain the whole ecological balance. Because there is almost no bacteria to replace them. Um, However, they may have a low metabolism rate than their mesophilic counterparts. This means that the cold condition may contribute to slowing the metabolic activity and the slow process of converting organic waste into ammonia. Many species of psychedelic ammonifiers can be found in inhabited landscapes such as cold marine and freshwater systems, mountain biomes, and ice areas. They also can be found on the industrial scale in waste and wastewater treatment systems in cold conditions. Um, the next slide shows the first result of my laboratory study. My laboratory study was made on the corpse of laboratory mouse. Um, and on the slide, you can see the list of taxa that were found on the soil and corpse itself. Um, I used a corpse of mouse because that body is easiest way to find out amplification processes and bacteria that takes part in it. So during my research, data was collected on the stacks, and here is a table of different biotopes of a corpse, as well as the spheres race. It's a colony forming unit and percentage of occurrence. The most frequently encouraged were acetamonicus firmans in bones, like 33% SPU on 145 milliliters, and in hair, 71% SPU on 49 milliliters. And Hermatium species in bones, um, 18 percent SPU on 49 milliliters, and also in soil, 43% SPU for 124 milliliters. The overwhelming majority of print taxa are mesophilic. And also there are two types of thermophilic microorganisms. My research wasn't concentrated on high temperature regions that are close to thermophilic microorganisms, but only a few of mesophilic taxa are found on the corpse respond to the conditions of my study, and they can grow and develop in temperature nearly 3 or 4 degrees, and they are bacterial fluorescence and Bacillus asparaginus. Uh, so my conclusions are the following. Based on the result of the analysis of data from open source, it can be concluded that not all microorganisms are function in low temperature regions will be psychophilic. But the activity also participate in ammonification processes under conditions of low temperature regions. The peculiarities of the function of ammonifiers at low temperature are due to difference of the structure, such as more acid structure lipids, formation of polysomes at low temperatures, and optimal enzyme activity in the same conditions. That's all. Thank you for your attention, and if you have questions, I'd like to answer them.
Thank you. So